Hello everyone, myself Anijay Pampani. So today I'll be diving into the world of queue data structure where I'll be explaining about the queue and its basic functionalities and also how to implement it in Python programming language. So what is a queue? A queue is a data structure which is used for storing and managing data in a specific order. Um, Follows the principle of first in, first out, or FIFO, where the first element added to the queue is the first one to be removed. So let's explain this with an example. Suppose we have a queue data structure here, and it's divided into, suppose we say, four parts. Okay, so here we'll have the number one, say number two over here, three over here, and four over here. So number one, it's the first element to be added to the queue. So when we are removing any element from the queue, number one is would be the first one to be removed because that was the first element. So and then it goes on like that. The second element which was added is the second element to be removed. So basically, queue is a linear data structure and which operates like a line where the elements are added at only one end and removed from the other end. Now let's talk about the various operations of queue data structure, the basic operations. So the first one is enqueue. Then we have dequeue. Then we have peak, the size, and finally the is empty operation. So the enqueue operation is to add an element into the queue. The dequeue operation is to remove the element. So when we remove, it would be the first element which was added. The peak operation is to show the next item, the next element which is there in the data structure to be removed. The size shows the number of elements which are present inside the queue. And finally, the is empty operation is to check if the queue is empty or not. So if we take a real life example of queue data structure, we could say a line of queue in front of, suppose, a movie theater. So the first person who is present in the line gets the ticket the first. So that's the exact same thing which happens in the queue data structure also, which is the first element is removed from the queue uh, at first. Now, since we are done with the operation and logical part, let's move on to the coding part. Okay, so here first we need to create a class queue. Uh, then what we have to do is we need to define each of the basic operations which can be done to a queue data structure, which I've explained earlier, with such as enqueue, dequeue, etc. So let's begin with it. So first we define init self. So this is to initiate the queue. The self dot items equals. So this is the first definition. Then we have defined is empty self, which was to check if the um, queue is empty or not. So return self dot item equals result. When we have defined enqueue self dot items, self dot items dot append item. So this enqueue is to append or add an element into the queue. Then we have dequeue. So dequeue operation has two conditions, which are if the queue is empty, then this operation cannot be used. Dequeue can only be done if there are any items left in the queue data structure. So first we give the condition if self is empty, then we print that the queue is empty. Else turn self dot items dot pop. So if the queue is not empty, then we pop the latest the item which is there 0. Then we define peak operation. So peak also has two conditions which are similar to dequeue. So which is the if the queue is empty, then there will not be any elements to show. Uh, so if self dot is empty, print queue is empty. None else return self dot items with uh, indexing as 0. Then when we give the index as 0, it will show the first element which is present in the queue. So that's for peak. Now we define size. So we return the length of the queue. So len self dot items. So these are the basic operations which can be done to a queue. Now let's implement these functions. So we start with if this is we're simply giving a name for the queue. So we name it queue equals. We start with the queue. Now let's add some elements into the queue. So queue dot enqueue. Now suppose we add the number 1. Uh, let's add a few more numbers. Q dot nq2, Q dot nq3. 7 q dot enqueue flow. So we've added these four numbers into the queue. Now let's try on these basic operations which we define. So let's begin with the size of the queue. So print queue size, queue dot size. Now, when we run this code, it will show the queue size is 4 since we added 4 elements into the queue. Now, let's move on to the next operation. Let's check the peak operation. So, print uh, element, element in front of the queue, and we can just give queue dot peak. Now, when we run this, it will show element in front is 1 because 1 was the first element which was added into the queue. Now let's try out the next operation. Let's dequeue one of the, let's dequeue the element. So we can show the element which is being dequeued. Queue dot dequeue. So when we run this code, it will show dequeue is 1. This means that the first element which was added, which is number 1, has been removed from the queue. Now let's again check the size of the queue, just so that we understand it. Run element queue dot peak. When we run this code, after being dequeued, the next element which is in front of the queue is number 2, because 2 was the next element which was added. Now let's again dequeue another element. So dequeue queue dot dequeue, and let's just check the front element and the element which is in front. Queue dot peak. So when we run this, we can see here that the next element which was dequeued is number 2 because that was the second element added, and after removing the number 2, the number of element, sorry, the next element which is in front of the queue is number 3 because 3 was the element which was added the third. Now let's just check out the size of the queue after dequeuing 2 elements. So queue size is queue dot size. Now, when we run this, as you can see, queue size is 2 because we have removed the first 2 elements. And over here, we have removed the number 1 and number 2 from the queue. So the remaining elements in the queue are 3 and 4, which is why the queue size is given as 2. So these are the basic operations of queue data structure, and hope you have understood about the queue data structure and its operation and also how to implement the basic operations. So thank you for watching.